shortest way to form string. So let's just read the problem first. So a subsequence of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relative position of the remaining characters. So basically we don't need to do that because normally we should understand what is a subsequence. So for example, this ACE is a subsequence of A, B, C, D, E because we can delete A and because we can delete B and D, and the relative sequence is ACE. So this means this so ACE is a subsequence, so it is ACE, while AEC is not. So normally we should understand about this one, even we don't read it because we've already understand what is a subsequence. And we are giving the source and the target, and we're gonna return the minimum number of subsequence of a source such that their concatenation equals to target. So basically we want to find something, some subsequence from the source and concatenate all those subsequences to make a target. So for the first example, we can choose like ABC, and then we're gonna choose BC. So how many steps? It's gonna be 2 steps. Yeah. So for the second example, because there is just a D inside this target, it means it is not possible because there's no D inside the source. And for third example, we can choose a subsequence of X and Z. This is also a subsequence, and then we're gonna choose a subsequence of Y because there's no YX. And then we're gonna choose a subsequence of X and Z. So there are 3 steps. Yeah. So basically, how can we solve it? And the length of the source and the target is 1000. So we can check the target. If there's some characters inside of the target, for example this D, which is not inside of the source, definitely it's not possible, right? But if all the characters inside of the target is also inside of the source, it means it is possible. Yeah. So we're gonna have a check first. So it's set of the target minus set of we're gonna do the set operation first. Minus set of the source. If there's still something inside, so for this example, there's gonna be a character D inside. But for this one, there's no character inside. It means it's possible. Yeah. So even for this source, there's another character, maybe A. It is still possible because it doesn't matter. So this is why we're gonna use the target minus the source. Yeah. So if there's still something inside, basically it means it's not possible. We're gonna return a -1. Now let's just return a random value 0 to check. So as you can see, the second case works. Yeah, because basically this is what we are checking. If there's some characters inside of the target D, which is not inside of the source, so we're gonna use the set minus operation. So it means the set difference. Yeah. Now what are we gonna do? We're gonna just use brute force to check the final result. Why? Because according to the greedy idea, now if it is not like that, basically it is always possible. So if it is always possible, what are we gonna do? We just check the character one by one. So for this ABC, and we're gonna check the source from ABC. So this ABC is possible. So we're gonna go to the next pointer. It's gonna go to B. So we're gonna go to this B and this C. It is possible. So the result is gonna be 2. Yeah, we just use a 2 pointer to solve the problem. So we're gonna prepare a result to 0. So this is our final result. And let's just prepare the length of the target. And let's just loop through the target. Now what are we gonna do? We just loop through the target string, and we're gonna use a while loop to check. Yeah. But before we use the while loop, let's just set a pointer J, which is gonna be 0. So we're gonna check. Yeah, so we're gonna check the source one by one with the target. Yeah. So let's just use this way. Maybe let's just use j as our target. J as our target. So while j, we're gonna use a while loop first because this is gonna be easier to write. While j less than n, then we're gonna use for tag, because for this source definitely we're gonna tag all of them. So it's gonna be, yeah, for, let's just use enumerate. So for I say in enumerate this source. So we're gonna have a tag if j less than n, it means j is inside of the boundary, and target j equals to, yeah, so this is the source equal to say. So if they are equal, what are we gonna do? We're gonna just update the j. So for example, this j is less than n, and then we're gonna enumerate and we're gonna tag. So for the first character, this a equal to this a, it's okay. So j gonna goes to here, yeah. And then for the for loop, so it's gonna go to the next character, it's gonna be b, and b equal to b, and it's gonna go to c, and c equal to c. Yeah, so this is exactly what we are doing. So now this j goes to c, and then as j goes to c, and here is also c, they are equal. So this means j gonna go to b, yeah. But here, we've already finished this source, and there's no b. Yeah. So next, what are we gonna do? We're gonna just use the for loop to check next. So yeah, because we've already finished, and now we're gonna use this for loop to check next. So for I in enumerate, yeah, the source. So if j less than n and target j equal to c, if this a is not equal, but it can go to b equal to this b, and it go to the next pointer, go to c, and this c equal to c, and it gonna go to the next pointer until it breaks the while loop. Yeah. Now we're gonna use the result to update how many steps. Yeah. So for each of the case, we're gonna update a result after the for loop. So the result gonna be updated to result plus 1, and finally we're gonna return the result. Yeah. Maybe it is confusing because I didn't explain it so well, but this is the basic idea. Let me just make a drawing here, maybe just to explain it better. So we're gonna have A, B, C. This is for source, and here is for target. It is A, B, C, B, C. So for the first case is that for the second example, if there's some character D inside the target but not inside the source, we can use this kind of set operation to check if it's not possible. Now, definitely after that, this area, it means it is always possible. So if it is always possible, so we're going to use the greedy idea, and we're going to use the two pointers to check one by one. So first we're going to start in from this character A and this character A from T. Yeah. Now we're going to check one by one. So if A equals to this A, so the pointer gonna go to B, this pointer gonna go to B, B equal to B, the pointer gonna go to C, this pointer gonna go to C, and then C equal to C, this pointer gonna go to C, and what's gonna happen for this one? Yeah, because currently this is J updated to this character B, but this for loop also finished, right? And we're gonna update the result, gonna be 1. And then what are we gonna do? Yeah, we're gonna just start from this J, because currently this J goes to B. And yeah, we're gonna continue to compare this B with this A. So this B is not equal to this A, it's okay. We're gonna go to the next. Next, this B equal to this B, it's okay. So they're gonna update it to C, and then we're gonna check next. C equal to C, and then the J updated to the next. But currently this J yeah, after finishing this j, the result gonna plus 1, result gonna be 2, and this j gonna equal to n. We're gonna, yeah, just break the while loop, and we're gonna get the final result. Now let me just submit it to check if it works. Now as you can see, it works and it's pretty fast. And I think this is gonna be the best way to solve the problem, because basically we're gonna just use a two pointer to solve it. And the time complexity, let's just check. So yeah, for the time complexity, basically it is just a string matching, and for the target it is 1000 and source is also 1000. Basically from here we just check the target one by one. So for example, from here we found something, and then for here we found something. So the time complexity is just on, even there's a while and for loop, but this is a two pointer. It means for the target it can never go back. It always go to the right. Yeah, even for this even for this source it goes back, but for the target it never goes back. So this means the time complexity gonna be on. Yeah, I hope we understand it. Yeah, because for the source definitely it can go back this for loop, but for this target, for each of the time, definitely we're gonna update the target. So because of this for loop, we're gonna just speed up and update the target really fast. So that is why the time complexity is gonna be on instead of on square. That is why it's so fast. Thank you for watching. See you next time.